diffusible, but this is indiffusible. After equilibrium, what happens? After some time, there is an exchange of sodium and chlorine will takes place, but these colloidal particles never move. This colloidal particle R1 is never move, but whereas sodium and chloride both are, exchange will take place, movement are across the membrane, but colloidal particles are not diffusible even equilibrium reached also. That is the main principle involved in the donor membrane equilibrium. And apply the conditions of electron neutrality, that is positive and negatively charged on the either side of the membrane must be balanced. The following equation written, that is outside sodium ions is equal to chloride ions, and inside sodium ions is equal to chloride ions plus colloidal. R1 is the colloidal. But here the colloid will not movement. Only the movement is sodium as well as chloride. There is a movement or exchange will take place, but never the colloid cannot move. Okay. The concentration of electrolyte on both sides of the membrane must be same. Then what happens? Concentration of sodium and concentration of chloride, that is always equal to initial, and at equilibrium is same. Both the concentrations are same. But converting chloride ions or concentration, the chloride ions concentration of chlorides and concentration of here also same, but the difference is while you were exchange, this R1 is colloidal particles that cannot move. The movement is only from sodium and chloride, both will move, but the colloidal particles are never move. That means finally the equation is, this equation represents the donor membrane equilibrium. This equation is mainly useful for calculating the ratio of concentration of diffusible anion outside and inside the membrane at equilibrium. From this equation, sodium CMC, in order to enhance the absorption of drugs of a sodium salicylate, this is increase the absorption, this donor membrane equilibrium is helpful. Last property, that is optical properties. Optical properties means light scattering or Tyndall effect, electron microscope and ultra microscope. Light scattering is also, we can call it as Faraday-Tyndall effect. Faraday-Tyndall effect. How means a beam of light pass through the true solution, the path is not visible. Suppose the same beam of light is passed through colloidal dispersion, the path is visible. Why? This is because of the scattering of light by colloidal particles, so that the path of the beam become visible. That effect is called as Tyndall effect. You see this is the flashlight. In one beaker we have taken a true solution, and another beaker we have taken a colloidal. You see the light. Light cannot see in a true solution, but the path is visible through colloidal dispersion. Because of colloidal dispersion only, the path is visible. This effect is called as Tyndall effect. Electron microscope. Electron microscope, the particle size and shape and structure can be determined by using electron microscope. The radiation source is a beam of high energy of electron, is having wavelength in the range of 0.1 angstrom. 0.1 angstrom. The electron microscope has high resolution power. Because of that high resolution power, we can observe. We can give the photographs of actual particles. Okay, ultra microscope means these particles appear spots as a light against dark background microscope. It is used a technique for microelectrophoresis for measuring of particle size. For example, you see this is the light source, and this is the hollow cylinder for light. This is the corridor for condenser, and this is the sample containing a colloidal dispersion. There is a scattered light. This scattered light will be split. We can observe under ultra microscope. All these we can observe under ultra microscope, you can see the effect. Then light scattering means it is depending upon Tyndall effect. Depends on Tyndall effect. It is used to give the information about particle size, shape, and determination of molecular weight of the colloids. This method is used for shape, size, and molecular weight of colloids can be determined by light. It is used to study the proteins, association colloids, and hydrophobic salts. Hydrophobic salts. The scattering described in terms of turbidity. That is, scattering of light described in terms of turbidity, that is T. What is turbidity? The turbidity is a fractional decrease the intensity due to scattering as the incident light passes through 1 centimeter of the solution. The turbidity is proportional to the molecular weight of lyophilic colloid. That is, spectrophotometry is used, nephelometry is used. Spectrophotometer, it measures the intensity of transmitted light. Intensity of transmitted light means this is the light source, this is incident light passed through sample. Immediately the light is easily passed through this sample because it is a colloidal dispersion. After transmitted light, we can see the intensity measured. The intensity of light can be measured. For example, lyophobic colloids, they may produce high turbidity. Suppose always lyophobic colloids, they may produce high turbidity, that is high scattering, low transmittance light. Whereas lyophilic colloids having low turbidity, low scattering, and high transmittance light. That is the difference between the lyophobic and lyophilic colloids. And whereas then here nephelometer means the scattered light intensity of the light is measured at 90 degree. This is applicable for lyophobic colloids. And the light scattering is mainly depending upon the turbidity. It is used for especially for study the proteins, polymers, association colloids, lyophilic colloids. It is used to measure molecular weight of polymers. The main principle is very simple. The light source, that is particular wavelength, the dimensions of the particles, and turbidity is measured in scattered light. Okay, here the light source, and that is split into light source incident light, that is followed on the sample, the colloidal sample, and how much scattered light intensity is measured. Depending upon the scattered light is measured in intensity. That means spherical, suppose spherical micelle plus light is scattered in all directions. But suppose the laminar micelle plus light adjust the direction of light. That is the difference, this one, nephelometer. And here the stability of colloidal dispersions means, suppose it is a stable system. Suppose if the stable system means flocculation will take place. Flocculation means all the particles are come together. They may lead to coagulation. After coagulation, immediately sedimentation will take place. After sedimentation, immediately phase separation will be there. Here one more is sedimentation means all the particles are settled at the bottom. There is a formation of a flocculation. After flocculation, coagulation will take place. After coagulation, phase separation will be there. That means in stable system, the particles are dispersed uniformly in dispersion medium, that we can say stable suspension. Stability of colloidal dispersions means, here the stability is for most important. The good colloidal dispersions having should not change until usage. The colloidal dispersions is having Brownian movement means that is very good stable one. If it is precipitated, that we can call it as unstable one. The stability region means lyophilic colloid, solvent sheath is and a particle is formed. Lyophobic means electric charge is present on particles. Lyophobic colloid stability means these thermodynamically they are unstable. In this system, particles tends to form aggregate. These dispersed particles are highly charged, and stability of the dispersion medium is explained DLVO theory. DLVO is Darjugin, Landau, Verwey, Overbrick theory. This theory will give based on distance between the two particles. Distance between the two particles and their interaction will give. The colloidal particles exhibit Brownian movement or Brownian motion. They causing the collisions of particles. The amount of electrolyte that are present in controlled stabilization and precipitation. Here, DLVO theory says that according to this theory, the distance between the particles of dispersed particles mainly influence the particle-particle interaction. Particle-particle interaction. Using this theory, we can approximately determine the amount of electrolyte required for the precipitate or stabilize the colloid. Then only we are going to get a stable colloids. The interaction between the particles are described as follows. Particle interaction means van der Waals attraction forces, the chemical nature and size of the particles attraction curve, and electrostatic repulsive force, density of surface charge, thickness of EDL, repulsive curve, zeta potential is stable range, that is 20 to 50 MV. Net energy interactions, that is algebraic addition of two curves. That means here this is the primary minimum and secondary minimum. This is the repulsion potential and attractive potential. This is the van der Waals equation. Always this total potential is required for secondary minimum. That means the conclusion from this theory means primary mean particle, they are close together, the atomic orbitals are overlap, the potential energy is increased, they aggregates. And whereas secondary minimum particles are separated, that is 1000 to 2000 angstrom, attraction will be there, aggregate is there, used for controlled fluctuation. Whereas net energy peak means any intermediate distance, that is 3 to 4 angstrom units, attraction is equal to repulsion, thereby Brownian motions will take place. Then due to that Brownian motion, the stable colloids obtained, that is zeta potential is 50 MV, and peak height is proportional to stability. Instability, lyophobic colloid, breakage of potential energy barrier, they may lead to precipitation and agglomeration will take place. Due to that agglomeration, the colloid is unstable. Instability method means reducing the height of potential barrier, increasing the kinetic energy, reduces the potential energy. Instability region. Instability means removal of electrolytes, addition of electrolytes of opposite charge, and addition of oppositely charged colloids. And here, removal of electrolytes means colloids. In colloids, if you are added electrolytes, we are going to get a stable colloidal dispersion. Suppose if dialysis method, if you remove the colloids, the particles are coagulate, they settled bottom. And whereas addition of excess electrolyte means the stable colloidal dispersion plus excess of electrolyte, if you are added, electrolytes are accumulate and instability will take place. And addition of electrolyte oppositely charged. Suppose the stable colloidal dispersion is there. If you are added extra amount of electrolyte oppositely charged, what happens? Attraction between the particles and flocculation of particles will take place. Once the flocculation of particles means stability problem will be there. Okay. Addition of oppositely charged colloids. Suppose bismuth colloid is there, it is positively charged. Tragacan colloid, if you are added negatively charged, immediately the coagulation takes place, that is instability will take place.
Right.